Hey all, this is Zach, your Lumix creator. How many colors can you see here? I mean, it's obvious, right? There are three colors here, red, green, and blue, right? Wrong. You see, our camera looks at color in a very different way compared to our human eyes. Generally speaking, most of the time, your camera can only see three colors, the red, green, and blue, also known as the RGB. However, by mixing these three primary colors and mixing them together with different color brightness, intensities, and different shades, your camera can give birth to a lot of other different colors. And how well a camera can do this depends on the color depth it can achieve. The name may sound a little bit familiar to you, no pun intended. We all heard this before, 10-bit, 8-bit, but what exactly is a bit? Take a look at this chart. With every increment of the bit, the range of RGB increases exponentially. By the time it reaches 8-bit, you're not looking at only RGB, but you're looking at 256 different shades of RGB. When they're mixed together, it can produce up to 16 million different colors, giving you a very realistic looking image. Now, most of the screen, including your phone, your TV, playbacks in 8-bit color. However, if you would like to take it to the next level, you may want to explore with higher color depth, such as 10-bit. A very commonly used color depth in professional video making. Usually you only see the option to record 10-bit in more video curated camera, such as the GH5, GH5 Mark II we have right here. 10-bit with just 2 more bit more than 8-bit produces 1024 shades of each primary colors, thus giving you a much richer color. How rich, you ask? Well, 8-bit has around 16 million colors. 10-bit, on the other hand, has around 1.07 billion possible colors. But wait a minute, if my TV can only play 8-bit, then why do I even bother to shoot in 10-bit? Now, turns out shooting in 10-bit gives a lot of flexibility for video makers when doing color correction and color grading, especially when doing green screen or you want to show a smooth gradient of a color. Now, see these artifacts in the details? This is caused by the lack of color information. In a simpler words, the camera does not have enough color to represent the true color of the object you are shooting. Now, this can be solved by shooting at least 10-bit colors and export it in 8-bit so that your TV can play it back. But that's not all. When you look at the product features, the bit is often accompanied by a series of numbers, such as 10-bit 422, 8-bit 420. So what are those numbers? That 3 numbers at the end there is called the chroma subsampling. It is the reduction of color resolution in digital component video signals in order to save storage and bandwidth. In simpler terms, we use chroma subsampling because if we record the true color pixel by pixel, the file size will be significantly larger. So in order to save space, we take advantage of the human eyes. The whole chroma subsampling deserves its own video. However, to make it easier to understand, the higher the number here, the more color you have. High-end cinema camera used in Hollywood capture 444, which has no color reduction, which a lot of professionals will capture in 422, which is good enough even for most broadcast standard. So there you go, the color depth. In short, if you hope to have more flexibility in post-production, you may want to consider shooting a greater color depth, such as 10-bit 422, which you can record internally in 4K in camera such as the GH5, GH5 Mark II. If you have any questions, feel free to comment down below. I'm Zach, and I will see you next time.